how prevalent is it out there that data scientists need to have cloud skills?
Cloud resources is not only a plus to train your machine learning models, it has become a necessity. I practically only use AWS when I want to do data science or build machine learning models.
On the cloud, the cloud provider just automatically updates them, releases new versions. You can just switch to those with a click of a button. There's so many companies using the same infrastructure, the cost goes down. So the prices for cloud are very low. You outsource a lot of your headache. First people that jump on this train will be prepared for the future of tomorrow, which is coming really fast.
Kirill and Hadelin, you guys were just here. What brings you back? Where are you guys calling in from?
Same places, I think. Oh no, I'm still in Australia. Hadelin is in France now.
Yes, I'm in France. I'm in Paris.
Nice. Paris. Hopefully everyone's heard of it.
It's unpredictable to know where Hadelin is. He's been between Paris, Mumbai, and Dubai probably like 50 times in the past year.
Yes.
Every time we get on a call, I'm like, where are you today? And it's a surprise.
And it's critical to ask if listeners don't know where you're calling in from, they can't enjoy the podcast episode properly.
For sure.
So awesome. Welcome back to the show. So last time you were on the show, we did an episode. It was episode number 649, and it was focused on your machine learning level 1 course. And so we did like a machine learning 101 episode that introduced the key concepts in machine learning. And we talked about how in the future you would have a machine learning level 2 course, but that's not why you're here today. So you have other things going on. For our listeners that aren't already familiar with you, you're two of the most productive data science education content creators out there. So of course you have more than one iron in the fire. So tell us about what you've been working on besides your machine learning course.
Okay, so basically last year we made a big and important decision, which is to extend our teaching to another industry, which is the cloud computing. So basically, that doesn't mean we're not gonna, move away from data science and machine learning. We are going to continue teaching machine learning and data science, but you will see in this podcast episode, we will talk about this, that there is this serious convergence between data science and cloud computing. And so it's not only a plus to teach cloud computing, it's going to become a necessity. And that's why it makes total sense for us to make that decision and teach cloud computing along with data science. So so yes, we made that decision last year. We've spent the whole year learning, working super hard on becoming experts in the cloud, and now we're very happy and ready to extend our offerings and teach about the cloud.
Nice, for sure. I don't want to step on your toes too much because I know we're going to have lots in this episode on why this is so relevant to data scientists, but just really quickly up front that with data science data sets getting larger and larger and larger and the models getting exponentially larger, cloud is a no-brainer for people to be learning about as well, because you need to be able to scale up your infrastructure to be handling all these data and these enormous models. So it makes a lot of sense to me.
Absolutely, John. And I also wanted to say there that that's why we got curious about it. Like we were, it's a technology. We just know it kind of happens, but we wanted to learn more. And as you said, we'll talk more about the why data scientists should learn the cloud. But I also wanted to add on what Hadelin is saying is that I wanted to be very clear and upfront with the audience that we're not here as data scientists who are dabbling in the cloud or who want to, be advocates for data science in the cloud. We for the past year, we've actually shifted, we've pivoted while still, being here for our data science audience, and we're releasing courses in data science from time to time, like the machine learning level 1. But we've actually pivoted and we're completely immersing ourselves in cloud. So what we're doing now, this new project, is relevant not just to people in data science who want to learn cloud, but actually anybody who wants to master cloud, who wants to get AWS certified and go through that. So in this episode, our goal, we're not here to make sales pitches or anything like that. Our goal is to educate and show, give a preview of what we've learned in the past year to the super data science audience. And, hopefully people can walk away and be able to have some level of beginning level of conversations about the cloud with their peers and colleagues. And if anybody at the end of the episode is curious about what we're doing now with a project we're working on, and wants to join us in this journey of learning the cloud, then we would be very happy for that. And there'll be some great, exciting things we'll be sharing towards the end of the episode about this as well.
Yeah, so I know you're not here primarily to be pushing anything commercially, that this is an educational episode on cloud technologies and why they're relevant to data scientists, but you guys have also just launched a new platform, right?
That's right. Yeah, so exciting! It's launching this week as the podcast is going live. It's called CloudWolf.com. You can find it at www.cloudwolf.com. And yeah, super pumped about it. So Adlan can tell us more a bit why we chose the name Wolf. It was his idea.
Yeah, absolutely. So first, yes, we think that the wolf is a fascinating animal, but also it has some, symbolism around it that can be described with a few words, which are intelligence, strong family ties, loyalty, what else? Education, communication, community. With the wolf packs. So we thought, it's a perfect description of the values and principles we want to have for a cloud wolf. The wolves for the cloud of the cloud, and yes, that's exactly how we see cloud wolf and how we see the community that we're going to build. We see, a lot of education, a lot of intelligence, because indeed the cloud is very technical. So you need to have the right intelligence of the cloud, which we will teach, of course, and also the strong family ties, loyalty, the community, because we see in Cloud Wolves, people helping each other, people yes, giving advice, supporting each other, so that they all get to a great level in the cloud.
Nice. That's really cool imagery. Nice. So, really exciting platform. Why should data scientists be learning cloud? I gave a couple of examples up front that we have lots more data than ever before, and those data sets are getting exponentially larger over time. Model sizes are getting exponentially larger over time. But why can't we just entrust that to other people? I guess like
Good
other
point.
kinds of practitioners. Why should data scientists themselves be capable of handling their own cloud infrastructure?
That's a good question. Let's to paint a picture. Let's start with what is cloud of, like as the first stepping stone. Because what is cloud? Because just to make sure everybody's on the same page of like the benefits of using cloud. So basically, a company can have IT infrastructure on premises, but then it has to worry about buying the physical servers, maintaining a physical space for them, maintaining security, managing those servers, servicing those servers, and like investing upfront a lot of money. That's called capital expenditure. Whereas with the cloud, you don't need to do any of that. You basically rent servers or rent storage or databases, whatever you need from a cloud provider such as AWS, Amazon Web Services, Azure, Microsoft Azure, Google Cloud Platform, or there are several others, but those are the three main big ones. You rent those things on an as per needed basis. So if you need some servers today, you rent the servers today, and you don't need them tomorrow, you release them tomorrow, you decommission or stop using them tomorrow, and you're paying an operational expense. You're no longer investing capital expenditure up front. You're paying an operational expense, and it's very flexible. It's very agile. You have access to way more different options. You don't have to guess your capacity in advance, your capacity or your needs. You need to train a big machine learning model this week. You have big servers this week, and then you don't need to train it. You don't need to pay for them. So it's a much better costing type of model. The infrastructure is shared, but at the same time, it is very secure, and so your data is not seen by the other companies using the same infrastructure. And basically, you outsource a lot of your headache. And the other big part is that there's economies of scale, because other companies such as Airbnb or Netflix or Johnson Johnson, huge companies, Coca-Cola, McDonald's, are all using cloud. And because there's so many companies using the same infrastructure, the cost goes down. So the prices for cloud are very low. And that's the attraction for business. So that's cloud in a nutshell, the benefits that you get there. And in terms of data scientists, it's mostly about where data science is going. And maybe Adlan can talk about this a bit.
Yeah. So basically, today to build the machine learning models and data science models, you need more and more compute intensive resource to train them. Simply because the models are, on the one hand more advanced, but also sometimes you have much bigger amount of data, and so you know cloud resources is not only a plus to train your machine learning models, it has become a necessity. And that is why there is this very strong convergence happening between data science and the cloud. Because indeed, now data scientists, in order to train their machine learning models, they will need the cloud resources, which include, two main types of things. First, the compute resources, which are the virtual servers with high and strong and powerful GPUs, and also storage, because we will talk about this later in this episode. You will see that in order to build machine learning models with the cloud, you can connect to the storage services of, for example, AWS and the compute services to build your machine learning models. And we will talk about that in a few moments.
And in addition to that, like if we even think, for example, of ChatGPT, which is completely entirely cloud-based. It's using Microsoft Azure. It's got 175 billion parameters. It gets 100 million users per month. That is a massive scale that is just very hard to maintain something like that on premise infrastructure. You'd have to buy lots of servers. You'd have to be scaling all the time, buying new servers. And then what if the demand drops? Like they're paying millions of dollars for this. I think it was like $100,000 per day to maintain ChatGPT, and that's thankfully because they're using cloud. If it was fixed infrastructure, it'd be much more expensive. So we're just seeing this, one of the biggest examples. But that's where the world is going. Like we're going towards much heavier compute intensive models and much more users that you will need to be servicing with these models and products that are being created. And that's why data scientists have to learn. It's like, I think Atlan already mentioned, is learning a cloud for data science is not just an advantage. It may look like an advantage today, but it is actually becoming a necessity. And the first people that jump on this train will be prepared for the future of tomorrow, which is coming really fast.
Nice. Every company wants to become more data-driven, especially with languages like R and Python. Unfortunately, traditional data science training is broken. The material is generic. You're learning in isolation. You never end up applying anything you've learned. Posit Academy fixes this with collaborative, expert-led training that's actually relevant to your job. Do you work in finance? Learn R and Python within the context of investment analysis. Are you a biostatistician? Then learn while working through clinical analysis projects. Posit Academy is the ultimate learning experience for professional teams in any industry that want to learn R and Python for data science. 94% of learners are still coding 6 months later. Learn more at posit.co/academy. That makes perfect sense to me. And this explanation of the size of the ChatGPT model, and that's now orders of magnitude larger with the GPT-4 release that happened recently as well. And so this is something these models, these large language models, are getting bigger and bigger and bigger. And while there are also research efforts to try to make ways of pruning away aspects of the model that aren't contributing overall or aren't contributing to specific tasks, we nevertheless have this ongoing trend of bigger and bigger models. So, so how prevalent is it out there that data scientists need to have cloud skills?
Yeah, John, it's very good that you asked this question, because there must be a realization from people that cloud skills have become a necessity. It's not just a plus, an advantage. It has become a necessity. For the very reason that we just mentioned, which is that machine learning models, data science models are becoming more and more complex, and therefore now to train them, well, the only solution is cloud resources. So yes, it's a necessity, and I think that this convergence between the data science and the cloud is gonna become narrower and narrower. It's gonna converge more, and the more it converges, the more cloud skills will become absolutely necessary to train the models. So yes, I think every data scientist now should at least know how to, for example, train a machine learning model with some AWS services, which we'll talk about in a few moments.
Yeah, and so AWS recently became a sponsor of the show. They had no influence on the content in this episode. This is
Yeah.
purely it's a coincidence, but I understand that because AWS is the leader in cloud, so the three main providers are AWS, Google GCP, and Microsoft Azure. And actually, I got the order wrong there because it's you guys dug up these stats, but
Yeah.
you looked up from Statista.com that AWS has 34% of the cloud market, Azure 21%, and GCP 11%. So I guess it makes sense. Maybe this is your recommendation that given AWS has more market share than the other two combined, if you're going to start with one of these platforms, you should start with AWS.
Yeah, that's about correct recommendation. And I also wanted to add that in terms of number of data science jobs that mention cloud skills, we did our own research and we made sure to check it for statistical significance or make a proper statistical research. So we wanted to come into this podcast saying that if you learn cloud skills, your salary is going to grow by X%. And we did find a slight increase in the average or the median salary of a data scientist from who's learning cloud versus the one who's not learning cloud, but unfortunately wasn't statistically significant, so we wouldn't be comfortable sharing that. But what definitely is a fact is that the number of jobs. So right now we found we looked at a sample size of about 190 jobs on Glassdoor literally yesterday, and we found that 37% of them, these are data science and machine learning jobs, 37% of them mention cloud skills, whether as a requirement or as a preference. And based on the sample size and doing a statistical test, we can say that overall in the world, not in just our sample size of 190, overall in the world, this number is somewhere between 34% and 40%. So between 34 to 40% of data science and machine learning jobs already today, at the beginning in the first quarter of 2023, mention cloud skills as either a requirement or or a preference. And that's a big number already. It's already growing, so it's over a third. And another thing to mention about AWS, since you asked, John, of those of all data science machine learning jobs, about 20% of them mention AWS skills specifically. So not only AWS has the highest share of the market, but also it's a safe bet. Like, unless you know that a company that you want to work for or that you are working for is using Microsoft Azure or Google Cloud, then sure, learn those. Those are very good tools as well. And we're planning on learning them as well. Like, once we're confident, like we've done our first few certifications with AWS, we want to move on to those as well. But if you don't know which cloud platform to learn, start with AWS. It's a safe bet. There's lots of companies using it, from large businesses like mentioned before, Nike, Coca-Cola, Disney, all of Netflix. People might not know this, but all of Netflix is on AWS. They don't even have their own servers at all. All their videos, everything, their websites is running on AWS. Airbnb is running on AWS as well. So big companies are, and also startups, because it's so agile to spin things up. So whether you're looking to work for a big company or a startup, AWS is a safe bet to add to your skill set.
Yeah, from my perspective, getting startups going for the last 8-9 years, it's a no-brainer. Like, I've built a couple of servers for doing a lot of computation prototyping for my data science team, where I knew I was going to need really big GPUs and that these instances were particularly expensive. Like, I did the math and was like, okay, to have a couple of these on premise, we can save a little bit of money because we assume that we're going to be using one or two of these all the time. But for the most part, like any production infrastructure, you need your machine learning models. You don't know how many users you're going to have at any point. So you need to have your infrastructure, your production infrastructure scale up. And then even with this example of us having these data science servers on-prem, well, because models are getting larger and larger all the time, when we're doing intensive computation, we need to be turning on cloud instances anyway. So we might do a little prototyping on like small amounts of data on our local instances, on our on-premise instances, and then use the cloud when we're like, okay, we're going to use this full Google T5 model now on a huge amount of data. And this T5 model, I couldn't possibly fit it onto the 1 or 2 GPUs that I have on this one server on premise. We're going to need lots of compute in the cloud. So yeah, it's a no-brainer to me that data scientists need to be making use of cloud infrastructure for training models today, and especially for production inference, because yeah, you don't want to buy all of the infrastructure yourself to be able to handle the maximum number of users at any given time point that you want to be have using your application.
Exactly. And also, what you mentioned about these servers, they get outdated. New technology is coming out all the time. And you buy these servers, you put them on premises, and then 2 years later, you need to decommission and sell them. Whereas on the cloud, the cloud provider just automatically updates them, releases new versions. You can just switch to those with a click of a button, and you're not having these kind of like sunk costs that you have to deal with all the time.
Mm-hmm. Yeah, for sure. So our listeners might be out there now convinced, if they weren't already, that they need to have cloud skills. Should they be intimidated, or is this like a really it sounds complex? It sounds like there's lots of language that we might not be familiar with. As data scientists or as machine learning experts, this cloud realm has all kinds of new vocabulary, new concepts. Are they like complex to learn, or is it relatively straightforward?
I think Kirill and I we can agree that yes, it is a bit complex at first. But John, you just said that it's a no-brainer. I agree with you. At some point it becomes a no-brainer because we get the intuition of how things work. But even if at the beginning, it can seem quite complex, well, Kirill and I agree that we make the complex simple. We've done that with artificial intelligence, so there is no reason why we shouldn't do it. Shouldn't be able to do it for the cloud.
What a great answer. Makes perfect sense.
Yeah, we've spent like a whole year learning cloud, like in and out, like we normally do, and that's one of the reasons why you haven't heard from us, or listeners, our students haven't heard from us quite a lot. We wanted to do this incognito, so like we would only talk about it once we were confident, and spending a whole year of doing it, we believe we can teach it very effectively, and we've already created our first course, and we think that you can, like, our estimate is that with this educational content, we can help people get their first AWS certification, which is the Certified Cloud Practitioner, which means you've learned the basics of cloud, you understand all the vocabulary, you understand how to learn it, how to use it, and it's actually a badge, a certification badge you can add to your CV and LinkedIn. We think, we estimate that people can learn. We can help people learn in 21 days. So if at 2 hours of study per day, within 21 days, that's 3 weeks. Yeah, we're confident that we can help people learn AWS and get their first certification in 21 days. Within basically 3 weeks, you can be AWS certified with the very first certification and add that to your skill set.
Nice. Yeah, that doesn't sound too tough at all. And yeah, so I guess another big advantage, you've talked a lot in this episode about how these cloud skills are really in demand, that a large portion of data science jobs specifically mention cloud technologies. But I guess another reason why a data scientist should be interested in this is because it just adding this to their toolkit allows them to broaden the impact that they can make.
Absolutely. I'll make a comment on that from my, personal experience with AWS for data science. To be honest, now I practically only use AWS when I want to do data science or build machine learning models. And it's not because the data that I, train the models with is much bigger, as we said before, which is one of the reasons why we should, have the cloud skills with us to train a machine learning model. It's not because of that. It's because even with small data, well, the machine learning models scores, performance scores that I get are better and higher with AWS and SageMaker in particular. We'll talk about that. So yes, and that because it has the ability to, combine an ensemble of models, including the gradient boosting models, the neural nets models, and do a lot of hyperparameter tuning at the same time very efficiently because it uses good resource to do that, and I get the best score at the end. There is a good example. There is this data set that I use as a benchmark in many of our machine learning courses. For this data set, we obtain, when we hard code the models, or, when we use the classic libraries with our own resource, we obtain an accuracy of 94, 95%. And with SageMaker, with AWS, I obtained 97%. Simply because it was able to, combine this ensemble of models while doing a bit of parameter tuning, hyperparameter tuning, very efficiently. So yes, that's my personal experience, and that's why now I practically only use AWS for machine learning.
Nice. Well, as you get deep into the technical weeds there, Adlin, you start to sound like somebody that I should trust on cloud technology. You start to sound like you know what you're talking about, but you guys have only been diving into this for like a year. Why should we trust your opinions?
It's there's a couple of things. First of all, we love teaching, and we've been teaching the different topics for 7 years now, and we bring our teaching skills to the table, and that is very, like, we find is very portable. We can port that to cloud and use the same teaching methodologies, which is really cool. And our research skills, understanding. In addition to that, we've also are following this learning. We've also become AWS certified ourselves. And the final thing is that sometimes when you're a beginner, when you're learning something for the first time, you're better positioned to explain it to other people, because as an expert, you kind of get lost. You forget what it is like to be a beginner. And especially coming from the data science field, we know what data scientists pain points they have, what kind of like pitfalls are to be expected along the way. And so it's, for us, it's a no-brainer that the content we've created is by far superior to everything else that we've seen out there.
All right. So maybe you've convinced me, but let's do a quiz. So AWS is the biggest cloud platform out there. So tell us about the basics of AWS. What are the essential things that data scientists need to know about AWS?
Okay, sounds good. So we're going to talk about 4 different types of services. There'll be lots of services. So AWS has a total of over 200 services. There, we're not going to talk about all of them. We'll talk about four main types that are relevant to data science, and we'll mention a couple. First one will be compute. Then we'll talk about storage. We'll talk about databases, and we'll talk about machine learning. So the first one is EC2, which stands for Elastic Compute Cloud. And because there's 2 C's there, Compute Cloud, that's where the 2 comes from. So Elastic Compute Cloud is basically a way for you to rent a server, like a type of, like a device. Like imagine like on premises, it would be like a server rack or a computer that's doing the processing. It can have a certain number of CPUs, whether 2, 8, 16 CPUs, however many you want, and what what amount of storage you want. Do you want 8 gigabytes, 16 gigabytes, and so on. Same thing in the cloud. So there's these big server racks that they have, and they're split into these virtual machines. So virtual instances, they're called. You don't need to worry about the fact that they're virtual. You just say what you need, and it's completely isolated from other clients. And then you will get your 16 CPUs and, I don't know, 80 gigs of RAM or whatever, 80 gigs of memory, whatever you need to be running a model. So you can, and the benefits of doing this through the cloud, we've kind of mentioned a few of them, is that you can select the right size for the right job. You can use it today and not use it tomorrow. You only pay for what you use. You only pay for the computer resource that you use. You don't pay for it if it's sitting there idly and not doing anything. It's very agile. You don't have to buy anything and install in your servers, and you get access to the latest technologies out there. So they're constantly getting updated. So that's a service to know. So whenever you hear in conversation EC2, that is the Elastic Compute Cloud service of Amazon Web Services. And that's where most cases you will be doing your compute, even though we'll talk a bit about other ones when we talk about machine learning.
Yes, and now I would like to talk about S3, which is another very popular AWS service. So S3 stands for Simple Storage Service, and as the name suggests, it's a storage service offered by AWS. And it's completely insane because it basically offers virtually unlimited storage. You can store virtually unlimited amount of data within S3. So it can be any of your files. It can be CSV files, for machine learning. It can be even images, videos, anything you want in what we call buckets. And also the very powerful thing about S3 is that it has 99.99911 times data durability, which means that even within a billion years, you will not lose any item within your S3 storage. Plus, it is super cheap. It is only 2 cents per gigabyte per month of storage. And you even have a free tier option which gives you 5 gigabytes of storage that you can have for free. So yes, it's mind blowing that all the things you can do and with such a power. For this storage service in S3. But by the way, I'm talking. It's like I'm selling AWS, but not at all. I'm just in an awe. I'm just very impressed of how this storage service is so powerful and how you can use it in an unlimited fashion.
This episode of Super Data Science is brought to you by AWS Trainium and Inferentia, the ideal accelerators for generative AI. AWS Trainium and Inferentia chips are purpose-built by AWS to train and deploy large-scale models. Whether you are building with large language models or latent diffusion models, you no longer have to choose between optimizing performance or lowering costs. Learn more about how you can save up to 50% on training costs and up to 40% on inference costs with these high-performance accelerators. We have all the links for getting started right away in the show notes. Awesome. Now back to our show. Yeah, it is a good case in point on how you can do things with cloud storage. You can't possibly have that kind of reliability. I wasn't aware of that 11 nines of data durability, so 99.9999 whatever percent, where you wouldn't lose a bit of information in a billion years. That's wild to think about.
Yes, indeed. And like Adlan said, the awe is like, that's the feeling we've been getting throughout the learning. Like every time we learn a new service or about a new service, we're like, wow, that is possible. That can be done. Like on AWS, you can even control satellites if you really wanted to. Of course, like most of us will never need that service, but there's a lot. That's crazy, right? Satellites, blockchain, whatever, like this. Oh, it's interesting, very interesting how they're updating these technologies all the time. And speaking of a variety of services, let's talk a bit about databases. So we've talked about computing, we've talked about storage. Well, another kind of important storage for data scientists is databases, and we've got quite a few interesting points here. So first of all, whatever flavor of database you like, whether it's Microsoft SQL, Oracle, PostgreSQL, MySQL, MariaDB, all those databases are available in Amazon Web Services through a service called RDS. So whenever you hear RDS, that stands for Relational Database Service. And because all of these databases mentioned are relational databases, you can spin up any one of those. And of course, there's more. I'm just saying that the ones that you're used to working with are available in AWS. You don't have to learn something new if you don't want to.
You actually just really quickly, there's a verb you use there that I'm not sure if we clarified what it means, but you said it's very easy to spin up an instance. And that kind of phrase, what does that mean to our listeners?
What is an instance? What is spin up? All of those things. Yeah. So an instance is what we talked about is before we spoke about EC2 instances. Here we're talking about databases. They also need underlying resources. So when I say spin up an instance, I don't know if that's a term generally used in the industry, but that's how I use it. I see it like you're basically launching a database instance of a database. And you're able to put things in there, you're able to store it. And whenever you don't need it, you just spin it down, spin it off. I don't know, turn it off. So you can cancel it.
I've never heard anyone say spin down. But yeah, definitely spin up. And I think it's something to do with this idea of like, I'm guessing
the disk spinning,
a disk actually spinning, that you're like, when you press an on button, it's like, woo!
Yeah.
It starts spinning. Yeah. But yeah, I don't think anyone says spin down. You just
and that's a really cool transition. Close down, yeah. A really cool transition to what I wanted to talk about next is there's also a really cool database on Amazon Web Services, which is Redshift, and this is a data warehouse. And so, in order to understand the beauty of Redshift, we have to talk about something called OLTP versus OLAP databases, data storages. So OLTP stands for Online Transaction Processing. OLAP stands for Online Analytics Processing. OLTP, all of those databases mentioned before, Microsoft SQL, Oracle, Postgre, MySQL, they're designed for OLTP. You can use them for analytics. Sure, you can go in and create averages of your columns. You can find out, the medians, the standard deviations, whatever, build your visualizations and so on, run your machine learning models. But that's not what they're designed for. And this comes to disk, right? So on disk, these databases, they store, it's a very simplified explanation, and so this is how I understand it. These databases store their rows, like data from a row together. So you might have 15 columns in a row, and all of those values of that row, they're stored together. Then the next row, then the next row. That's because that's how they're written into the database. You write them row by row, and that's how they're stored on disk. Whereas Redshift or online analytics processing data storages or data warehouses, such as Redshift, what they do is they change, or they shift, hence the name, they shift how data is stored on disk. Now, all of a sudden, it's not your elements of a row are stored close together of each row, but now elements of a column. So all of the values in one column are going to be stored close together. All the values in the next column are stored close together. And why is this important? Well, because when we're doing analytics, when we're doing any machine learning model or any visualization, we're interested in things like features. We're interested in averages of those features, which are columns. We're interested in performing operations on columns, not on rows. And because they're stored close together on disk, that means your analytics and your machine learning is much faster. And that's what Redshift is all about. There's also, basically, I wanted to say that there's also a type of data warehouse which you can easily move your data into and use that for analysis. So if you have, terabytes and terabytes of data, that will really speed up your machine learning and other analytics. So that's on Redshift. Another really cool database is Elastic Cache, which is an in-memory type of database. Really fast, non-durable, so you can't really store things there forever. But it's not designed for that. It's more designed for like analytics, real-time analytics, if we're talking about analytics, or it might be some gaming analytics or some really fast things that you need to do, and you don't really need to store them. Another cool database is DynamoDB. Completely different type of database. It's non-relational database. It's schemaless. It's serverless. We're not going to go into detail about all those things, but basically, if you're looking for a NoSQL type of database where you can create your own schema per every row, that's the DynamoDB is your go-to, and it's basically scales automatically as you put more data into it. Very powerful type of database, and that's for our listeners who might be interested in NoSQL. In terms of, and of course, you can store JSON documents, you can store other types of data. If you're specifically interested in something that's for storing JSON documents in the NoSQL space, normally we would use MongoDB outside of AWS. In AWS, you have DocumentDB with MongoDB compatibility, which is their kind of version of MongoDB. Really powerful. So if you are used to using MongoDB and JSON document storage, then DocumentDB is your go-to in AWS. And those are just some of the databases. There's many more that we could be, or database services and related services we could be talking about. But one last one I want to mention is Amazon Glue, and that's an ETL service. So extract, transform, load. You have all these sources, whether it's the databases, whether it's NoSQL databases, whether it's your S3 data, like you have CSV files in S3 or something like that, and you want to combine all of that, put it together, do an ETL process, then Amazon Glue is your service to do that. So as you can see, like even the usual tools in data science that we use, in machine learning we use, they have everything covered, everything and much, much more. Like the possibilities are endless. So yeah, once you transition to AWS, it's like you can still use the skills you already know. They support that. You can learn additional ones, but basically your skills are very very portable into AWS services.
Nice, really cool. That was a really detailed introduction to the different kinds of database options that there are in AWS. I learned a couple new things in there. Like I didn't know, because for years now we've been using GCP and Mongo. I didn't know that there was a separate document DB that was comparable to Mongo and has interoperability. That's cool. And I didn't know about Amazon Glue. That sounds super useful for people who are engineering data pipelines. Those ETL, extract, transform, load pipelines. Amazon Glue sounds like a great tool for stringing all those different operations together.
Absolutely. There's lots more services we could talk about, but we don't want to overload our listeners.
Yeah, no, that's a great start. So once we've got our data into whatever format we want, like a structured database or a NoSQL database, and then we want to actually do some analytics or we want to do some machine learning, how can we do that in AWS?
Okay, so you have different services for machine learning in AWS. I will talk about the most popular one, maybe, which is SageMaker. And that's typically the AWS service to build machine learning models. And you have two ways of doing so inside SageMaker. The first way is with the SDK. I will explain what it is in a second. And the second way is with AutoML. So let's start with SDK. SDK stands for Software Development Kit, and it basically allows you to build a machine learning model classically on a Jupyter notebook, while at the same time being able to call for the AWS resources, such as EC2 if you want to get a compute instance, or storage, S3 if you want to, store your data sets in a storage service like S3, and then call, load the data set for your machine learning model. So you have your Jupyter notebook, you can call the SDK to get the AWS resources, while at the same time use the classic deep learning or machine learning libraries like TensorFlow, and you combine everything and you build and train your machine learning model. So that's the first way. Now the second way, which is amazing also, is with AutoML. And AutoML allows you to basically build your machine learning model, but not only that, build a whole pipeline of implementing a machine learning model without coding any line of code, without typing any line of code. It's basically with just some plug and play, just a few clicks that you manage to build this whole pipeline. So it goes through several steps. First, you input the data. So you first store your data in S3, and then you load the data in the first step of this AutoML pipeline. Then AutoML will automatically recognize what type of problem it is, like regression or classification. You just have to specify the target, and then automatically AutoML will recognize the features, the input variables. Then the next step, so you just have to answer a few questions, for example, on your data set, but generally AutoML will detect if there is any, for example, input variables to pre-process, like categorical variables. Then in the next step, that's where you're going to choose your training process. And you have three options. The first one is auto. So that's the option that will basically test an ensemble of models that AutoML usually detects as the best potential candidates for your data set. So, it identifies this fit between your data set and a good selection, potential good selection of models, and it will use these models to test them like in an ensemble. So that's the first option. Then the second option is basically train and test everything. So here you will just have in the pipeline all the TensorFlow models. You will have all the gradient boosting models, deep learning models, neural network based models, and others. It will test all of them, and it will return at the end, the best combination of models with the best combination of hyperparameters that leads to the best score. So that's, of course, probably the option that will give you the highest score, the best score, but at the same time, it's the most compute intensive, and also it's the one that is gonna take a lot of time. I actually waited a couple tens of minutes with this option. And the third option is just hyperparameter tuning focused. So it will not test all the models that are in SageMaker, but it will test, again, a good fit with your data set while doing a lot of hyperparameter tuning to make sure to find the best hyperparameters. And among these three options, the one that I recommend is auto, because it will generally be the one that leads to the best compromise between having the best score and not taking too much time. And at the end, without having implemented any line of code, you get your model, the whole code of the model. You get the training score, so accuracy for classification and mean squared error for regression. And then, you get amazing results. I tested it several times, as I said before. You get the best scores with SageMaker. And then finally, you can deploy this model because, you get this model as an endpoint. So you can use this model to then deploy it to make some new predictions. And so you can get this model, make new predictions on new observations. So, and that's really amazing because that's really also a way to democratize machine learning and data science, because now people without having, coding skills can train some machine learning models super easily. They just need to understand how to pre-process, the data, how data should be pre-processed, how the machine learning pipeline works, and then they are ready to do machine learning. So that's pretty amazing.
Yeah. So I have two questions for you. One is probably a short one, and then one is maybe a longer one. So the first one, the short one, is you mentioned the idea of being able to transform your model into an endpoint. What's an endpoint?
So basically, in SageMaker, you have in AWS in general, you have endpoints, which is the link basically to your model, or or to your instance, or to your anything. Any feature of AWS has an endpoint which you can access, which allows you to connect this to other resources. And here, this is for makes us to make some predictions. So you have your models, which you can access through the endpoint, and then you can deploy it to make some predictions.
Nice. Yeah. I think like maybe the kind of general idea there is it's like an API endpoint.
Yes.
So yeah, so
Yeah.
it's like this idea of microservices architecture where if you have all these discrete services
Yeah.
programmed in their own way, and then you have this endpoint for accessing whatever that service is. So it could be a model, it could be a data resource,
Exactly.
it could be any part of some production application. And so yeah, very easy to work with, and it's like the standard way of building applications today.
That's right.
And then the other question that I have for you, it's funny, I thought that was going to be the short one. But maybe this one will end up being the short one. I don't know. I think that this is kind of a more open-ended question. So you described how with SageMaker there, we can do all these incredible things. It can select our features for us automatically from all the data. It can pre-process those features. It can select from myriad different models and tune the hyperparameters on all of those different models and then ensemble them together into a super amazing model and then provide us with all of the summary statistics and allow us to quickly create an endpoint on this super amazing model. So why isn't everyone doing that all the time? Are there situations where we're better off having more control, or why does anybody learn how to make ensembles themselves or tune hyperparameters themselves if they can be doing it in SageMaker?
Yes, that's a very good question. I would say that it's because people probably think it's quite complex to use SageMaker and AWS. Maybe
Right.
there hasn't been that much training to democratize this. But indeed, as I said before, now I practically only use SageMaker because that's with SageMaker that I get these best models. And even by going with the easy option of selecting AutoML and just putting the whole pack of models in an ensemble and doing some hyperparameter tuning and get this. No, but seriously, I would say that the way to not use SageMaker is if you want to have indeed more control, and that's maybe in a research context. Within a research context, here maybe you have to explore more avenues on how you want to combine your models with the data to come to your objectives. But if you want to do a classic data science project with some classic machine learning predictions, yes, I would definitely recommend to go for SageMaker and AutoML. I mean, I don't think that more control is necessary to get to your amazing score that you need to get.
Cool. Great answer. Other than SageMaker, Adlin,
Yes,
any other ML tools that we should know about in AWS?
absolutely. So there are a lot of ML tools. So you have okay. So I'll tell you about one of my favorite, which is Deep Racer, because I have a particular preference for reinforcement learning. So yeah, you have AWS Deep Racer to test your reinforcement learning models for car racing. So that's pretty cool. You have also
Deep
Amazon
Racer?
Yeah, Deep Racer. Yeah.
Cool.
Yeah. You have augmented AI, which allows you to implement a human review of machine learning predictions. You have Amazon Forecast to make some forecast, for example, on time series predictions. You have Amazon Translate to do machine translation. You have Amazon Comprehend to do NLP. You have Amazon Recognition to do object detection and object recognition. So you see, you have many of them. You have basically an AWS service for every branch of machine learning, whether it is computer vision, NLP, machine translation. So you have Amazon Transcribe for speech recognition, and you have Amazon Poly also, which turns text into speech. Yes.
Wow, that is a lot of services.
Yes.
Yeah, and most of those I didn't know about. All right, so with all that, with everything that you've covered around EC2 instances and S3 buckets and databases and machine learning in the cloud. You've passed my test. You've passed my quiz.
Oh, I'm relieved.
Congratulations.
Awesome.
So I'm now happy to officially recommend your course to our listeners. So in lieu of a book recommendation, how about you guys fill us in on your upcoming course, the launch, and any other details that our listeners need to know so that they can learn about the cloud for data science from you two.
Thanks, John. It's been an honor to come on the show again. Thank you for tolerating us and inviting us. And hopefully, we were able to share. As I mentioned at the beginning, we're not here to make any kind of sales pitch or anything. Like our goal was to share some information with our or the Super Data Science podcast audience, so that they get some general knowledge about the cloud. And hopefully, we were able to accomplish that objective. And speaking of the project, as mentioned before, it's cloudwolf.com because because clouds are cool and wolves are cool. And just gonna say because wolves are cool, but I said cloud. Anyway, both are cool. It will be a membership, and there'll be lots of really cool stuff. We're building it up. We're going to be adding more and more things. This like when the podcast is live. This is literally the first week that it is available. So we have some very special things for the early wolves, not early birds, but early wolves. Most importantly, that you can lock in a very attractive price that is likely never going to be available ever again, because you will be part of the very first group of people. And of course, there'll be some things that we'll need to fix in the platform, some things you'll need to be patient with us with, and we'll be adding more content. But that means you can lock in this great price for your membership. Basically, we're starting off what we will have there eventually with time. We're going to be adding lots of labs on cloud. We'll have a community around the cloud and people who want to get AWS certified and want to grow together and learn these things together. We'll have study guides, exam samples, and so on. To start with, we're launching with some exam samples. We're going to have three exam practice exams for the AWS certification. And don't forget, this is focused on AWS learning AWS and getting certified in AWS. And we'll have this our first initial course on the AWS Certified Cloud Practitioner exam, which is about 14 hours long. It's quite a big course. There's lots of services, but as mentioned before, we expect that with about 2 hours per day, it can be done in 21 days. But it covers lots of things, and what we're proud of is we really focus on our educational style, because there's so many services. We couldn't afford to just talk in our videos, so we made our videos very concise. Our video average length is about 3.5 minutes per service or per part of service, so it's very sharp to the point, kind of like what you experienced in the podcast today. We just straight to the point, what it's about, what you need to know, how to use it. As usual, I do the theory, Hadelin does the practical. So that's our main offering. But in addition for that, because we come from data science and because we have this data science legacy and we love data science and machine learning, we couldn't help ourselves but include a special bonus mini course, which Hadelin will tell us about just now.
Yes, and that special bonus mini course is Data Science in the Cloud, where we teach you how to use and mostly leverage the AWS resources to build and train your machine learning models and eventually get to that best score we were talking about during this podcast episode. So we use SageMaker, of course. We use particularly AutoML. I'll teach you how to very easily use that whole and build that whole machine learning pipeline with your data set first that you load, and then clicking a few options to pre-process your data set, then choosing among the three options of how you want to train your model, with this ensemble model or with this hyperparameter tuning option. And then I show you how to get the final trained model, the best model with the scores and the different features, and then I train you how to deploy your model. And also, by doing this course, you will understand, already a lot on AWS resources, because you will see that we actually use a couple of AWS services to, work with SageMaker, and this includes S3, but also IAM to manage your permissions within SageMaker, and EC2. So you will see it's already even if it's a course for data science, it's already a good introduction to AWS services, because we use the the main ones. And also you will see that I show you a couple more services like the ones we spoke about. For example, Amazon recognition. So I'll show you where they are and how to use them. Not all of them, but the coolest ones.
Nice. Sounds really cool. So you guys talked a fair bit there about the AWS certification. Why does that matter? Why should somebody care to get a special certificate as opposed to just learning the relevant skills?
Well, the good thing about cloud that we found is different to data science is somehow, because it comes from like this on-premises background with where servers and things have existed for decades and decades. It's very established in terms of the different pathways, career pathways, in terms of the different skills that people need to know. In data science, for now, we don't have a generally worldwide recognized certification. But I'm sure listeners would agree that if there was one, it would be a good idea if you already know data science, you already know machine learning. It would be a good idea to get certified and put that on your resume, because that's just like a stamp of approval. Same thing here. Like, you're going to be learning the cloud if you make this choice, if you choose to join us on this journey and learn the cloud and get upskilled in this area and add that to your school toolkit. Why not? Why not get certified as well and put that on your resume? Imagine like an employer says like AWS skills required or AWS skills necessary because they're planning on using the cloud or they're using the cloud. Who are they going to go for? Somebody who says they know the cloud, or somebody who has a certified badge from AWS saying that they do know the cloud? That, of course, in the latter option, the second option, it's much more preferable. And so just with a little bit of extra effort, why not get the certification? And they're valid for 3 years. So you get it now, you keep it for 3 years, and that's going to be very useful as well for your career.
Nice. That's crystal clear. That makes a lot of sense to me. And so just a bit of clarification here. So between the two of you, you've had many millions of students on Udemy. Is this course going to be on Udemy too?
Yeah, thank you, John. So first, we don't have many millions of students. We have 2, but that's a start, I guess.
2 students.
2 million students. But no, we're not going to be on Udemy, and that's for the simple reason that we really want to build this new community, this big community, and inside this community, we want to have more flexibility. So while Udemy offers a lot of great features, to communicate with the students, we will have a lot more flexibility if we can, host these new courses and build this community on our own platform. It will be much more interactive. There will be this better sense of community building, and with the Wolf Pack, so on CloudWolf. So I guess there is a lot more that we can do by having, building this cloud educational platform with our own community and with our own, website.
Nice. Crystal clear. Well, I wish you guys the best of luck. In fact, I feel like I don't even need to do that. I know that this is going to be tremendously successful, like everything else that you two have ever touched. And so really excited to see this course launch and have people be using it. I know the feedback is going to be great. Thank you so much for coming on the show, both of you, Kirill and Hadelin, and giving us a kind of a one-on-one episode for data science in the cloud. Thank you so much, and I'm sure it won't be long before we have you on again, giving us an introduction, an invaluable introduction to another critical data science concept.
We hope so.
Thanks a lot, John.
Thanks a lot.
Pleasure.
Always great to have Kirill and Hadelin on the show, as they're lots of fun and certainly do all their homework, coming to their episodes terrifically well prepared. In today's episode, Kirill and Hadelin filled us in on how the cloud platforms enable us to rapidly scale up and down compute infrastructure as needed, minimizing our costs in many common circumstances. They talked about how as data sets and machine learning models get bigger and bigger, data scientists will benefit from being proficient at using cloud platforms themselves, how AWS, Azure, and GCP are all solid options for most data science use cases, and given that AWS is the most popular of these services, they highlighted particular aspects of it, such as EC2 instances for compute, S3 buckets for storage, Redshift for an OLAP, that's online analytical processing database, that is designed for efficient data analysis operations. And Hadelin talked a fair bit about SageMaker, which is a really powerful tool for automated machine learning. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Kirill and Hadelin's social media profiles, as well as my own social media profiles at superdatascience.com/671. That's superdatascience.com/671. I encourage you to let me know your thoughts on this episode directly by tagging me in public posts or comments on LinkedIn, Twitter, or YouTube. Your feedback is invaluable for helping us shape future episodes of the show. And if you'd like to engage with me in person, as opposed to just through social media, I'd love to meet you in real life at the Open Data Science Conference East, ODSC East, which will be coming up soon in Boston from May 9th to May 11th. I'll be doing 2 half-day tutorials. The first tutorial will introduce deep learning with hands-on demos in PyTorch and TensorFlow, while the other half-day tutorial, which is brand new, will be on fine-tuning, deploying, and commercializing with large language models, including GPT-4. In addition to these formal events, I'll also just be hanging around and grabbing beers, chatting with folks. It'd be so fun to see you there. All right, thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another super useful episode for us today. For enabling this super team to create this free podcast for you, we are deeply grateful to our sponsors, whom I've hand-selected as partners because I expect their products to be genuinely of interest to you. Please consider supporting this free show by checking out our sponsors' links, which you can find in the show notes. And if you yourself are interested in sponsoring an episode of the show, you can get the details on how by making your way to johnkrohn.com/podcast. And of course, thanks to you for listening. It's because you listen that I'm here. Until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.